Hello, let's model this scissor lift in Onshape. We will start in the Part Studio with simple sketches and create those 4 parts: the base, the pin, the scissor, and the rivet. And then we will go into the assembly, assemble those with plenty of mates, revolute, sure, as well parallel, planar, cylindrical. Then we'll make a sub-assembly of those 3 here and insert that at the back, and then define the motion with a distance made in the parallel limits. We will define limits and the parallel mate. All right, so let's start in the Part Studio with that first sketch for the base. So I start a sketch on the front plane, N normal to that, P to hide the planes, and then a center rectangle from the origin. Dimension that with 166 and 22. Then I'll draw one construction line here, something like that. Dimension that, length 48 and 12 from the outer edge. And then I'll go into the slot command, take that, and give it a diameter of 12 millimeters. Then a circle over here. We can apply that same diameter here between those two, and that same distance, 12. All right. That's it. We go into extrude, take that region, make a symmetric extrusion of 88 and call that part base. And just change the appearance a little bit, a little lighter. Okay. So from that same sketch, we will extrude that pin. So I take that region, say new, again symmetric, and that will be a 104 millimeter depth. Call that pin and give that some yellow. All right. Next is a sketch here on the front plane. and that'll be just a line. Starting at that center point of that arc and go in here to the center point of that circle. Make that a construction geometry. Project with U that edge, and well, over there we will just draw a circle constrained by that arc, and here in the center midpoint constraint, make those equal again like that, and go back to that slot command. Take that and change the diameter to 16. Accept that and extrude that region here, including that one. 4 millimeters as a new solid. Okay. I call that part Scissor and give it some kind of green here. Okay. Okay, so the next thing is the rivet. I take that as my sketch plane. With U, project that circle and a symmetric extrusion of 8 millimeters. Rename that rivet and change the appearance to red. Okay, and that's it for the Part Studio, really. Well, we can, for convenience purposes, apply 2 mates in here. Let's hide those 3 for a moment and define 1 mate at that sketch point for that base. So I go into mate connector, take that edge here, that point. The owner part is that one. There you see it. The z-axis oriented like this. Okay, hide that. Hide our part and make that same thing for our pin. Here, owner part pin. Okay, great. So let's go into the assembly. Insert, well, all of that. Let's just pull things apart first. Go to that base and apply a fix to that. And then let's start with the revolute mate of that one and that one. Okay. And next I will just duplicate that component, Control C, Control V, and make a revolute mate by hovering over that edge here and over that one. All right. And well, do that once more for our rivet here and that one. Okay. And now let's apply that revolute from that edge to that edge. Apply. Okay, let's enter exit that mate command and see. All right, so this is moving like that. That arm is moving like this. So let's insert one more base. Control C, Control V. And apply that revolute mate here. So that edge and that one. Yeah. And well, we could just to get things oriented, apply a planar mate between that side and that one. Okay, so this is moving the way we want it. And now we can copy that one, the pin, maybe just 4 times. And apply that revolute again here with that one. Ah, no. The top one, huh? That one here. Accept that. And one more time. That edge with that one. And we'll apply that once we insert that sub-assembly of those 3 here. All right, I select the 3 components, hover over that blue area and make a right mouse button click and go to move to new subassembly. So there it is, that assembly 2 within our assembly 1. I take that, Control C and Control V. And the relationships we get between those 3 are copied. Okay, before continuing mating those here, I need to acknowledge that I made a mistake, and that is the position of that pin here. With that scissor arm, that should be, well, parallel with that, but what we're going to do, we're going to have a look at that. That is this relationship, and we will edit that and change it from revolute to cylindrical. And that liberates that pin in this degree of freedom. All right, and now we will apply that mate here, that revolute mate. So take that, okay. Okay, now let's use the cylindrical mate to mate those two here. Solve that. And sure enough, revolute mate of that edge and that one here. All right. So we still got that one here. So apply revolute mate here from here to there. So let's see. Things are moving the way we want, but we see there is that collision, that interference. So that is what we're going to define with the parallel mate, and then define the limit within that parallel mate. So parallel, that is here. Take that mate connector here. Take that. Accept it. And let's see. Okay, nothing has changed so far. So let's analyze how far we can go with that pin in that direction before it collides here. And we can do so with the tangent mate. Take that face with the tangent propagation. Take that one. All right, that might have gone the other side of the face, so turn that around. And let's see. So all good, all good. Go up till here. There, huh? Let's measure that here. Take that face, take that one. There is a distance of 84. Minus 84. Okay. So we get our parallel mate here. Let's edit that with limits. And so I type in minus 84. Maximum is 0. Accept that. And now let's go into right mouse button click on parallel 1, animate. Take that Z axis here. We see start value, end value, steps 300, that's the speed. Reciprocate, sounds okay. And there it is. If you like the video, please leave a like, a comment. You can subscribe to my channel. And I talk to you soon.